Hi everyone, this video will cover the quotient rule. We've already covered what the product rule is, we've covered the chain rule for differentiation. So in this video we're going to talk about quotients. Quotients are just functions that can be written as fractions like this you see there. So one way we don't need the quotient rule, one way we do. If we look at part A, we can just divide each term there by x squared. So we have 1 over x squared minus x squared over x squared, which simplifies to x to the minus 2 minus 1. Now we can just differentiate each term and get that answer there, negative 2x to the minus 3. So that's simple to do. We don't need any special rules, we just divide by each term. However, part B, we're going to need a special rule called the quotient rule. Now I am not going to show you how to do the formula for the quotient rule. You can look that up, but here it is here. The derivative of y, where we can express y as u over v, two different functions, u over v. And this is the way it's printed on formula sheets. The way I remember it is u dash v, so the derivative of the top one times the bottom one, minus v dash u, so the derivative of the bottom times the top one, it's v dash u, divided by v squared. These are always printed on formula sheets, so should have no problem. It's just a matter of applying it, so I'm just going to show you a few examples of how to apply it. Let's go to the examples. First one, differentiate x squared over x plus 1 to find dy dx. Notice we can't divide that here, you know, there's nothing simpler, no simpler way that we can write that function there. So I'm going to say the top line is u and the bottom line is v. We then do the derivative of the top line and the derivative of the bottom line and use the formula. That's it. Just be really careful here again, defining u and v in these steps here. For shorthand, you could write that as u dash, and this is v dash, but it should be no problem there. Just substitute everything in. So u dash v, so that is 2x times x plus 1, minus v dash u, so 1 times x squared. So you get this cross thing going again like we had in the product rule, but you've got to get the order right in this case because it's minus on the top line. And the bottom line is divided by v squared. There we go. Now that's our answer, but we could tidy it up. So let's simplify that. The top line, let's expand out the numerator. We get 2x squared plus 2x minus x squared, collecting the like terms, x squared plus 2x, and then factorize the top line. That is a much nicer way of writing that. Again, if you now want to know when is that derivative here equal to 0, that gives you the turning points. That's a good thing to know. I can clearly see that when the top line is equal to 0, this fraction will be 0. So the x values would be 0 and negative 2. That's where there's a turning point. Also, negative 1 is interesting. We can see that when x is negative 1, we get something divided by 0, which is undefined. So clearly, the derivative is not defined at when x is equal to negative 1. And if you went back to the original function, you could see that you've got an asymptote there, so the derivative is not defined at that point. You can turn all quotients into products. So if we look at this, e to the x over 1 minus x squared, you can write that as a product by taking the whole bottom line and putting it to the top. That's fine, but it is a lot of times more awkward. So if we just use the quotient rule for this one, we've got u equals that and v equals that, no problems to differentiate those two. However, if we use this version and do the product rule, the second one is a lot more nasty because we have to use the chain rule. I think it is a lot easier most of the times to use the quotient rule where you actually have a quotient. Okay, so let's do one more example. X squared over 2 minus x. The top one we're going to define as u is x squared, the bottom 2 minus x. Do the derivative of the top, the derivative of the bottom, apply the formula. It's that simple. So u dash v, 2x times 2 minus x, minus v dash u, minus 1 times x squared, divided by v squared, 2 minus x squared. Again, simplify the top line, expand the brackets, 4x minus 2x squared plus x squared. And we've got some like terms that we can do there, and then factorize. So again, the slope of this curve is 0 when x is 0 or 4. And we've got something weird going on at x equals 2. Go back to the original function, you can see the function is not defined for x equals 2. That's it, that's the quotient rule.